So, hello everyone. I'm Joshua. I'm working with the head tracking team for HoloLens. So, broadly speaking, as you'd guess, that job entails tracking the head. And so this presentation will be going through some of the more esoteric places that we need to track people's heads, specifically moving platforms. You know where we are? Okay, so that's me. I'm the one that's not the robot. And so I have a background in robotics, and I've been at Microsoft for about 2.5 years now. Okay, so we're going to be talking about moving platform mode, which here's a tautological example, a mode for when your platform is moving. Okay, we'll go through exactly what all this means. There's some terms here that are kind of ambiguous to people who aren't doing this particular project, so we'll make sure you understand all these things. Okay, so product statement, what are we here to try and do? So moving platform mode aims to allow the HoloLens, specifically HoloLens 2, to work inside moving platforms. What does moving platform mean? This is one of those overloaded terms, which is very hard to Google, unfortunately. But it's any kind of environment that's moving. So the really obvious examples are things like cars or trains or planes. But there's less obvious ones like oil rigs, for example, the vehicles that look kind of like not vehicles, but they are in fact vehicles, or things that are really not obvious like skyscrapers. So if you're at the top of a very tall building, we can get some tracking issues because of the slight sway of the building, or if you're on top of a crane, for example, if you're the operator of a crane. These kind of environments are kind of pseudo-stationary, but in fact will have poor tracking using a normal HoloLens. A really, really strange one here, production lines. So for example, if you were a worker who's doing welding on a car production line, for example, and perhaps you were doing this welding whilst the car moves along the production line, if you're on the inside of that car, or the primary visual features were inside the car, then you would also need to use this mode. So there's some strange situations where it's not explicitly vehicles, but this would be useful. And of course, your esoteric example here, there could be strange things I haven't thought about this mode would help with. So there's some secondary things that this mode does that it helps us do. So we needed to allow the designers of the system to select the best way of turning this on or off and setting certain things. We'll go into details about that in a slide or two. And we also need to enable experiences where the idea of down or gravity starts to become ambiguous. Of course, on a moving platform, which way is gravity facing is a slightly more complicated question than it is in a stationary room. Okay, I'll give a brief timeline of the feature, because it is a new feature, so you may not have heard about it before, or you may have only had a brief go with it. So it was developed during the COVID era. This is when I was in Zurich, but the rest of my colleagues were here, so it was an international kind of development thing. So that was for over about 2 years during COVID. And last year, we did an initial release. So you may have had your first go with it then if you've had a play with it. This was only through dev unlocking the device and going through the device portal, so it wasn't really fit for prime time yet. In February of this year, we released what we'd say a full release of the feature that includes management features and other kind of non-feature specific, but useful for management of the feature. And then very, very recently, you may have seen it, we released a blog post that detailed some of this kind of history with some of our partners, specifically VW. It's quite an interesting read. I do recommend it. And of course, here we are today. So you can see it's a fairly new feature. It's only been out and about in the proper wild for a handful of months. And so one of the things that I would like this presentation to do for you is to give you some examples of this feature working in different environments. I'm going to leave a lot of the how to use the feature or how to do Unity stuff or whatever to online documentation, because that stuff is difficult to follow along and remember in a presentation like this. But hopefully I can impress on you the level of performance you would expect in different environments, because some of them you would expect very poor performance and some of them you expect very good performance, and it's hard to do that in online documentation. So that's the value add here. Okay, so let's dig in a little bit to let's take a little time for just any questions with the setup here, and then we're going to go through actually the problem that it solves. No immediate questions? Okay, cool. So from a technical point of view, I'll outline just briefly what problem NPM is solving and how it solves it. So the HoloLens, if you've had hands on one of these devices, they have a number of cameras on the front. Specifically, there's 4 cameras that our team is concerned with, which are the head tracking cameras. You can kind of see, this isn't the best image, but they're the ones that are on the side here. There's 2 on each side, and they're kind of bunched together. And we also have an IMU, which stands for Inertial Measurement Unit. It's a pretty standard abbreviation these days. And so one of the primary functions of the head tracking team is to fuse these sensors together and output a combined estimate of the head position. Because either one of those sensors could do an okay job of estimating that, but they can only do a good job together. Specifically, the IMU provides like low latency information, but would be very poor in an absolute sense. And the cameras provide very good absolute measurements, but are poor for latency. So those together are very important for head tracking and giving us the steady holograms that you've come to love and expect from HoloLens. Though we do have a problem. So when the environment is not in the inertial frame, there's an issue. So the IMU is measuring our velocity, or it's measuring our acceleration and our rotational velocity relative to the inertial frame. And so the inertial frame is kind of an abstract concept, but you can imagine it kind of the grid space of the universe, as it were. And it's giving us those accelerations and velocities relative to that. And for our purposes, we assume that the planet is more or less the inertial frame. Of course, there's some rotation of the planet and stuff, but we can ignore those for the most part. They're just in the noise floor, so we can ignore them. Whereas the cameras are measuring our head position relative to the room itself. So it's going to pick out features and corners and give us some estimate of how far away they are. And with enough of these features, we can estimate our position over time, relative to where we started. So one is relative to this abstract inertial frame, and one of them is relative to this like very concrete internal environment of the room or the vehicle. And of course, when those two things disagree, any algorithm that's assumed that they agree with each other is going to fail. And the standard status quo for the industry is to assume that the environment is in the inertial frame, and all of the algorithms assume that. And so the normal HoloLens algorithm does assume that. And so if you take a normal HoloLens without moving platform mode on a plane or something, it will try and do its best guess of fusing this inertial frame referenced measurement and the environment referenced measurement, and it will do a very bad job, and it'll get lost and complain, and it's not worth using. Whereas this algorithm will account for those things. So a useful analogy for this is if you've ever gone on a boat and you've become sick, then this is the same mechanism. Your inner ear acts a lot like an IMU. It's measuring your head rotation and acceleration relative to the inertial frame. And your eyes are measuring relative to the inside of the boat. And so this is why you end up getting sick, because your brain is assuming that those two things are usually the same, which they usually are. And so that's why some of the cures for seasickness is to look out into the actual sea, because then you end up having your eyes referencing the same inertial frame as the inner ear is. So it's the same mechanism, and it's useful to think about it that way when you're trying to work out how this feature works. Okay, and so of course the solution is that we account for the moving of the vehicle in our state estimation. So we have an extra few states, and through the miracle of Kalman filters, we can get a much better estimate. And it is better in basically all vehicles than the original algorithm, but it is just very slightly worse at estimating its position inside a stationary room. Because of course we're giving extra constraints or extra variables to estimate, and therefore it's going to do a less good job of the pre-existing variables that we need to estimate. So this is why it's not the default. Lots of people ask that, why don't you just have this as the default mode? Because in a stationary room, if you're never going to go on a vehicle, it's slightly worse. Like if you're a connoisseur of HoloLens head tracking, you'll definitely be able to notice it. The average person who just plunk the device on the head, they might not notice it. So it's up to you as a designer of the system to do that trade-off yourself, and we wanted to let you do that trade-off and not make it default without your input. Okay, so there are 3 ways of turning the mode on. and they leverage. Well, you should use different ones for different scenarios. Let's put it that way. So there's the Unity API, which is for developers to turn it on and off via their application. We also have Windows configuration, also known as MDM, which is mobile device management, although everyone just refers to it as MDM, which is more for system administrators. So if you've ever gone into if you have a corporate laptop or something and you want to go change the firewall settings or something and it says, oh, you're not allowed to do this, that's this kind of setting that's kind of forced on by your administrator. And finally, on-device settings, which is more for the end user to make this decision. And it's also probably the most convenient way for a developer who doesn't want to bake into the app yet an API call, for example, because it's like a zero-code way of doing this. Okay, so we'll go through it. Hopefully this text is big enough on this slide, but one of the things I want to kind of encourage you to think about the way that you turn it on and how that fits in with your application. So one of the primary questions you want to ask yourself is, which agent in the system knows that you're on a moving platform? So if your system administrator knows that you're on a moving platform, then you should definitely try and use MDM. It's the most reliable solution. So this is, for example, if you were a shipping company or something, and you know the HoloLens is always going to be on a ship, and you don't want the user to mess with it. Because, of course, if they turn the mode off, then the HoloLens is going to stop working, and you're going to get a support call to your IT system or your IT administrators. So if your system administrator knows that it's always going to be on a moving platform, then they should just fix it on in moving platform mode. And that's super reliable. There's no way of the user messing that up. Next down the list, and these are kind of in priority order. So next, sometimes the user knows that they're on a moving platform. So they might be using an app that's not specific to moving platforms, like a calculator app or a game or something. And they know that they're currently on a ferry. And so they're going to go in and change this. So this is also very reliable and good. But of course, you're relying on the user to know about the mode, which is sometimes a risk. Like an unexperienced user might not know that. They could set it in the wrong mode or not understand what they're doing. So that's always a risk. But at least there's a way of them undoing it. They're in control. And then finally, there's the application layer that can make this decision too. So sometimes we've found some customers have, they're like a system designer. Perhaps they're designing an app specifically for another company. And they know that whenever this app is launched, then they must be on a moving platform. So for example, it's, I don't know, a HUD for a boat or something like that. So the pilot of the boat gets details from the instruments. Whenever that application is launched, they must be on a boat, therefore we should put it in moving platform mode. But perhaps that HoloLens is also used for dockside stuff too. And there's another separate app that when that's launched, they know they're on dockside. So they will never need to be in moving platform mode. So there's some situations where the application itself has inherent knowledge. And this is usually the case when the HoloLens is kind of a one-trick pony that's got the one application or the two applications that someone's designed for that use case, and there's never going to be any other app installed. So this is the last in the line of tools, I would say, because it has some risks. Of course, if you set the mode in a way that's the user doesn't know about it, they can be in a mode they don't expect, and they won't know how to undo it. Your program could crash when it was intending to turn the mode back again, and then it crashes and leaves it in an unexpected mode. So there's some risks here, but we wanted to make sure that for some applications this is the right solution, and we wanted to have that available. And there is detailed instructions how to do the API. It's very simple. You can turn the mode on, you can turn the mode off. You can query whether the mode is on, and you can query whether the mode is off. So those are the different options. But I'd recommend going in priority order, like the top one is the best, down to the bottom. Okay, and then there's a final strange definition that we need to go through, which is down direction. So we've kind of coined the idea of down direction to be different from gravity, because in the rest of the HoloLens system, gravity is the thing that we usually talk about. If you want your ball to fall towards the ground in your physics simulation, then it's going to be done based on the gravity vector that you can get from the Unity or whatever other game design system you're using. But in a moving platform, this isn't really a good way of doing it, because our system has some kind of caching that goes on that kind of fixes the down direction, because it wants to give UI kind of a consistent down direction. So for example, when you launch an app, the slate will be aligned to gravity usually. But if you did that on the boat, every time you swung on the wave, your window would come up on a different orientation and be fixed there forever, because once it's placed, it gets anchored. So we didn't want a situation where you'd end up with a load of windows at different orientations. So we have this down direction concept, which you can think of as the vector towards the floor, which in a stationary room is the same as gravity, but in a moving vehicle it isn't. And the vector towards the floor doesn't matter how your vehicle moves, it's still the same vector. So it gives us some kind of consistency in for the UI elements to stay orientated correctly. There are two ways of setting down direction. One is very convenient because you don't need to do anything. If you're in moving platform mode, the default behavior is it will take a long-term average of gravity. So if your boat is rocking, it will be looking at gravity over a roughly 20-second period of time. And then that average, long-term average, will be then locked into as down direction. And then from then on, it will use that instead of gravity for most purposes within the system. And therefore, all your windows will be aligned to that 20-second average of gravity. We picked 20 seconds because that's about how long it takes the system to boot and everything else. And so you probably won't see any artifacts coming about through the down direction changing over time. By the time it's booted and you've opened your window or whatever, it would have fixed that average already, as well as being long enough that it will take into account like the average waviness of a sea situation. So that's one way. You don't need to do anything. Excellent. The second way for some specific applications is you'd want to set the down direction particularly. Imagine a very simple example. You knew that your vernacular train, the trains that go uphill, you know that you want to align to the down direction of the train because it's kind of on a hill. And you know that in the parking bay of where the train is, it's always going to be on an angle. So you don't want to have the down direction be gravity as an average. You want it to be specifically towards the floor. Of course, our system can't know you're on such a train, so you need to tell it which direction is down. And we have a very simple mechanism for that. Inside the moving platform mode settings page, there is a down direction section, and you can just say set down, and that will take the vector from your nose to your heels, let's say, the kind of downwards in the headset space, and it will lock that as down direction. And then that will be used for down direction forever, in fact. So that will be locked into the map as well. It will be saved. It will be persistent across boot. But of course, you've put some effort, you've spent some of your own calories to set that down direction, and we don't want it to go away. Whereas the average one was done on every boot. So if you load into a space that there's previously been a user set down direction, it's going to remember that. It's going to load that in, and your down direction should remain persistent. So yes, there's some applications where you might not be on a moving platform and you want to set down direction for some other reason. Perhaps you're in a simulator of such a scenario, so you're on the ground. This isn't perhaps not a real space station thing or a rocket or whatever this is, but the person's doing some training and they're always in a reclined position. They want their UI elements to be facing them, not at a strange angle. So in that scenario, you might want to set down direction anyway, even if you weren't on a moving platform. You can imagine some strange scenario where people are reclined. We've heard some comments that this might be good for accessibility reasons, for example. People who are constrained to a bed, or temporarily or permanently, they might want their UI elements to be facing them, even though they're laid down. So although that's not like a formally supported thing right now, that's something you could try. Or if you have some strange moving vehicle scenario where you start off on a strange angle, then this is also useful. Okay, so that's the end of the presentation as far as like pure kind of me talking. Now I'm going to show you a whole load of videos, okay? So if there's any technical questions that relate to those slides, that might be a good opportunity. Can we have the microphone? Are we doing microphone for questions? Yeah, if you just speak nice and loud, that'd be great. Yeah.
But the fact that we are so either like any zero gravity environment.
Yes, so that's a very, very good question. So the question is, if I'm right in saying, does it work in zero gravity? So yes, it does work in zero gravity. In fact, we specifically, working through partners like NASA, queried them on what they needed. And of course, one of the things I say is we need it to work in zero gravity. So specifically, if you're in moving platform mode and you turn the device on, its automated way of finding down direction, it can't average gravity because it's going to be a zero vector and it's going to be noisy. And so it would end up picking a random down direction. So we have a specific carve out that if the measured gravity is below a certain value, then it's going to take your head orientation, just like if you press the set down direction, and that would pick that as the down direction. And it will run with that for the time being as its automated way of doing down. And if you then set a down direction using the button, it would work just in the same way. Like it will save that to the map, and it will recall that if you ever get lost and come back to the same space. So as far as we're aware, we haven't tested this in a real zero-G environment, so we can't guarantee anything, but it is designed to work in zero-G, and we do have offline tests for that. And yes, it's certainly if you have any more detailed questions, you can talk to me afterwards. But it does work in zero-G, and that's one of the cool elements of this project. Yeah, at the back there first. So the question is, can it auto-detect moving platform, or could it in the future? It could. At the moment, we decided not to, because there's some artifacts that are specific to the moving platform scenario. You'll see this in a video at the end. That there's some ways in which it breaks that's unexpected, and a developer who's been developing in stationary mode their whole HoloLens career doesn't want us to add a new breaking mode without kind of cluing them in. So we decided not to have any automated turning on of this feature, because it might detect, you go in an elevator or something, it will detect you're on a moving platform, which is good. But then it's going to introduce all of the problems that moving platform has, and we don't want to put that onto a developer without them knowing about it, because they might have already released the app and they might not be involved with it anymore. So we don't want to have that support requirement. Yep.
So the broader question, I guess, in my mind, is there, because you mentioned administration.
Yeah, so the source of data, this is an interesting question. So the question is, if I'm correct in repeating you, that we could have external IMUs that provided data from the boat or from the car, and we also have an IMU inside the headset. Have we thought about integrating those things together, or some system for fusing those? Is that the question?
Yeah.
Yeah.
Where should the IMU data?
So in the system as it stands, the relevant one is in the headset. So there's no external tools required, or no external systems that you need to install in your platform. It should work. You can go on a random public bus and it should work. That was the aim with this feature. We didn't want to bake in requirements that there had to be a system administrator of the public bus system that's going to let this work. We have done experiments using external IMUs that we decided for the ease of use of the end customer and the developers, that we didn't want to have external IMU on the network that required them to have a certain quality of network, as certain latencies that they had to meet, all these very strict requirements that would be necessary. We decided that we'd try and solve it entirely on the headset. And entirely on the headset is how it works right now, and it works okay. Like, we could theoretically get better performance using external IMUs, but with external IMUs, we have all this extra overhead that for some customers might be worth it, but for lots of customers, it's a huge pain in the neck. Okay, cool. Yes? Mm-hmm. Mm-hmm. So the down direction would be set at when you first boot. And so for that first 20 seconds, it will average the gravity, and down direction will be set from there. And then for the rest of the drive, that will be the down direction. And so it will stay with the car. As the car goes uphill, it will stay, if it's pointing towards the floor at the beginning, it will stay pointing towards the floor as it drives around. No, it's not a rolling window. It's the first 20 seconds. Yeah, unless you set your own gravity, and then it's an instant pole of the current head direction, then that gets locked in. And then for the rest of the drive, it maintains that. It's locked within the map. OK, those are great questions. So I will get on with showing you some videos. So this section of the presentation will hopefully get you a gauge of performance in different moving platforms, and might seed some questions as well from you about your own esoteric platforms or other things like that. OK, so if you've read our documentation on the feature, you can see that we're really focusing on ships and boats. This is because we believe it's a fairly solvable area. They don't accelerate too much. They're not too aggressive on average, or at least a lot of ships will operate in a sea condition that's pretty smooth. So we thought we could solve this quite well. And so we've tested up to sea state 4, which if you guys aren't mariners, which I'm certainly not, sea state 4 is like, you'll probably be sick unless you're like a professional seagoer. And it will work well up to there. We've tested internally, so that was with external partners, but internally we've tested at sea state 2 also. This video here is 2 also. As reference, a normal person, a non-seagoing person will probably be fine. They probably can stand up more or less, but they might end up being sick in the long run. They're likely to lose some motor control from the hands, because the hands have momentum and they're bouncing around like this. And so sea state 2 is what we've tested internally. So you can see here, this is the video of the ship on the outside, and on the side here you can see the way that I'm going to show a few videos on other vehicles is similar. We've drawn lines using a graffiti application that kind of roughly line up with features of the actual scene. Don't judge the feature based on how well lined up those lines are, because that's just done by someone by hand and they're not likely to do it very well. Judge it by the kind of high frequency content, how it drifts over time. So you can see it does judder slightly. Unfortunately, I haven't put a video of it not working because it's very boring to look at, but when you don't have moving platform mode on, it just gets lost. It just doesn't show you anything. It has, if you ever go into a dark room, you see the little mountains that say, I'm looking for your space, that's all it will show. So it's an infinite % increase in performance from that. But if you're worried about like sub-millimeter performance, you can see that there is some high frequency movement in the holograms. But these, another thing to note is that these mixed reality captures actually do us dirty a little bit. They make it look worse because the camera is quite narrow field of view. So it's kind of zoomed in on the things going wrong. Whereas when you're wearing the headset is actually vibrating too. And actually it turns out that the errors, the vibration errors here kind of correlate with the headset. And they kind of cancel out kind of automatically in a magical kind of way, purely by accident. Also, when you're bumping around in a vehicle, your brain has, at least this is my theory, this is a little headcanon here, but you expect things to wobble. If you're holding a book in a car and you go over a bump, the book will bump. And somehow that feels natural. When things are rigid, it actually feels strange. So in real life, when you're wearing the headset, you go over a bump and it wobbles slightly, it actually feels fine. If the video kind of makes it look a little less good than it actually is. Okay, so that's boats, our primary use case. But I will go through a whole load of technically unsupported use cases so that you can have a gauge. Okay, so the first one that most people will ask is cars. So there's a few disclaimers here. So this disclaimer will stay in the frame for the whole slide. Of course, we don't recommend driving with this. In fact, it's almost certainly illegal. It's certainly a very bad idea. And you guys should wait into the future when there's regulations have gone through about what's allowed to be on the display and all this kind of stuff. Airbag manufacturers and all those other people need to be involved in these discussions. And so do not drive with it in the driving seat. And even if you're not in the driving seat, you must do your own safety evaluations within your company or whatever. I'm sure they're going to ask you to do such things. So do be very careful. And if in doubt, don't do it. There's some other challenges in cars that are kind of specific to them. Lighting challenges. You're going to drive with sunlight that comes through and then it goes away, and the sunlight comes through and it goes away again. Very direct sunlight causes problems for our head tracking system. Also, you're going to want to drive at night, and unlike a boat at nighttime, you can just turn the lights on and it's more or less fine. I guess the bridge, they sometimes have the lights off. But in a car, you're not going to have the lights on inside the car. It's completely not safe. So you're just like any other HoloLens in any other scenario. If it's very bright or very, very dark, then we might have some problems. And cars have that scenario a lot of the time. Of course, we have intermittent violent motion. So if you go over a speed bump at high speed, you shouldn't expect it to track very well. And cars will do this more than boats do. They'll be smooth on the motorway for an hour, and then they'll go over a speed bump when you get to the local area. So this is one of the reasons why we can't support it directly, because we can't guarantee that it's going to have great tracking all the way through. Okay, and safety, of course. To end the slide again, you have to do your due diligence and operating heavy equipment in general. So if you're thinking about forklifts, all that kind of stuff, like even if you weren't the driver, if you're the operator of the heavy part of the vehicle, the crane or the forklift or whatever, then obviously there's considerations about workplace safety there. So let's get on to the videos. So here is me driving, or not me driving a car. I'm in the passenger seat here, as per safety protocol. And this is neighborhood and highway, both in the front seat. Sorry, that should be playing. So this is going only 15 to 20 miles an hour around the neighborhood area, and this is on the highway going 60. And so you can judge some vibrations here. Again, we've lined up some more or less features with some lines here. And my personal rating on this is it's like an 8 out of 10. It's pretty good. The wobbling that you see in the video, again, is less obvious in real life. But, of course, when you go over a speed bump, it could lose tracking, although I've never lost tracking inside a car, actually. So as far as reliability, it's very, very good. As far as wobbliness, pretty good. Not too bad. Okay, back seat. So there is a difference between the front seat and back seat in the sense that any feature points that the cameras see that are outside actually don't help us, because we want to track the inside of the car. So when you're in the front seat, you see a lot more windows. The big screen in front of you, and obviously the side windows right there. So you have less tracking points. So in theory, we should be more reliable in the back seat. Though you can see in the video here that the perceived wobbliness is actually higher, and that's mainly just because those features are further away. And so when they have a few degrees of bump, they kind of look more obvious. In reality, when you're wearing the HoloLens, they're about the same. They feel about the same as far as wobbliness, but it should be more reliable. And you're less at mercy of the sun coming in and ruining your tracking. So I'd recommend, if you have a car-based example, try it in the back seat first, that's going to be more reliable. Also, you can take some advice on whether it's safer. There's generally no front-on airbags in the back, although this isn't advice, I'm not an expert, but I've heard similar things said. It's better to be in the back. Okay, so trams, this is in Zurich. So if you've ever been on the Zurich tram system, generally they're pretty smooth with very high-frequency juddering. So this is a slate that's been put out. And you can see that it wobbles slightly, but it's actually very, very good. If you look at the line in the outside here, you can see that we're currently stationary, and then we start pulling away. And so during a pull away in a vehicle, especially a very smooth vehicle like a train or a tram, you're going to get just a slight vibration as it goes from a kind of semi-stationary mode. Like we do detect when it's stationary within a moving platform mode to tune the tracking so it's a bit better in stationary environments. And then when it transitions from a stationary environment to a moving environment, there's a slight juddering. But otherwise, it's very good. I'd say that you can design applications on trams, and you're going to have a good time. Okay, trains, of course, are quite similar to trams. So I must call out our good friend Asahai Sakamoto. He videoed this for us. He's in Japan, obviously. So this is on a Japanese train, which, from my memory, are very, very smooth. So this is probably the easiest vehicle. And you can see this is with the early version, so there's some down direction issues on this one, but you can see he's being able to navigate menus smoothly, and there's no problems at all. So I would say on trains, you're going to also have a good time in general. Okay, airplanes, again, thank you to Asahai Sakamoto for this, because he filmed it on the plane for us, or for the world, and then we asked his permission to use it. There we go, they're both playing. So this is, he filmed it during takeoff and landing. You'll see here, I've tried to shorten the video, so this is during landing on the side here. It's very, very juddery. I don't think you would be expecting to read any text or do anything too functional during landing. During takeoff is not too bad. We'd expect during cruising it to be completely fine. In fact, normal HoloLens works during cruising for the most part, unless you go through turbulence or you're doing a bank at the time. Yes, although doesn't come as an explicit recommendation that you should be doing these during takeoff and landing. It's just they were on YouTube, they're pretty cool, and it's should give you some information, I think. Okay, so elevators, or as in my native country they're called lifts. There's a few interesting points about lifts, or elevators, is that they're very, very common. They're probably the most common moving platform that someone wearing HoloLens is going to do, because they're normally in an office or something, and then they're going to go in the elevator, and then they're going to lose tracking. So in moving platform mode, they won't lose tracking, or they shouldn't do at least. But there's some extra considerations, just like there were in cars, that they're often very small rooms, so you're very upfront to whatever features there are. Also, they're almost always like satin steel, like brushed steel or whatever you call it. And so there's no features anyway. Or they have mirrors, which mirrors aren't necessarily a bad thing, but they do cause issues because you end up with most of the tracking features that are available are actually just yourself in the mirror, and then you move around and you can lose tracking. So they're difficult environments anyway. And they also have this special problem that they go from exactly stationary to a pretty decent acceleration in a way that's without too much warning, and our system obviously can get caught off guard slightly. So there'll be a slight, as you go upwards, there'll be a slight dip, and then it will catch up with you, and then it will be fine. So I can say you generally have a good time with elevators, but they do highlight I wouldn't say it's a bug, but it's just the way the system is that you build a map in your room, you go in the elevator, this becomes part of your map. You go up in the elevator, actually the whole map comes with you, and you go out the elevator and start building a map that's overlaid on your old map of the new room. So there's no, the whole system believes it doesn't move. That's one of the things to think about, is that in moving platform mode, the HoloLens is tricked into thinking it's stationary. And so it will build the map as if it is stationary. So it doesn't know it went up a floor. It's not building a map that includes a new floor. It builds the map on top of itself. So this is again, not really a bug, though we knew this from the beginning. But it's something to consider. So you might end up with corrupted maps if you do this too much. So we're not generally recommending using elevators in a way that you haven't thought about it well ahead of time. Like transitioning, in general, transitioning between moving platforms and stationary environments can be challenging. You might need to clear maps. You might need to do some crafty work to make it work well. Okay, and so a lot of you might think, well, did we do all our testing in these vehicles? We didn't. It's a pain to go into vehicles, especially when you have to have a laptop and everything's connected by USBs. So this is how we often tested it. If you have the privilege to go into Studio C at EVA, you might see this this kind of fancy swing. It's like a garden swing thing that's meant for fancy gardens. And so we got one of those and we covered it over with some blankets now. So we have this kind of enclosed capsule that we can swing around. So this is how we test it. And so you can see this video is, in the sub video, you can see an outside view of it, with the person inside. And then this person is now swinging the swing, and this video is the mixed reality capture of the person on the inside. So it's pretty trippy to try and work out what's going on. But you can see this as an example for remote assist, which I would say this is 100% usable. A remote assist, like things do wobble slightly, but I think for most applications, the fact that the thing you're circling or arrowing towards, or the PDF you brought up for someone is slightly wobbling, isn't going to stop your elevator service person or your oil rig remote guy won't stop them from fixing things, I don't think. And for even more esoteric ways of testing inside, this is how the early versions were. So this is when I was still in Zurich. So you can see I've got a HoloLens with light strapped to it, looking into a box, and then the box has all sorts of tape inside to help it have some features to track. And so this is useful as an example, because you see that this is full rotations reasonably quickly, even angular accelerations reasonably quickly, and it still tracks. There is some wobble, as you would expect, though this example is kind of cheating because, of course, I'm holding it and I'm making sure it's very smooth, whereas in real life, vehicles vibrate in a jagged way, and there's engine noise and everything else. So if you end up with very smooth, strange 3D motions, it also does work, though they're not common in nature, I don't think. And I think the final video is next. So this is, I'll have to explain this one first, so it won't play. So this is kind of a blooper. This is, I guess you could have predicted it. 10 minutes, yeah. You could have predicted it, but it did make me laugh when it happened. So what was happening was I was testing on a bus. So this is a Zurich bus here. And you can see up the top here, there is some windows that I'd been placing on the bus. And I'd done a capture, and it was a relatively boring capture of it working on a bus. But when I got off, I decided to have a look and see what the holograms would do. And so this is what happens to the holograms in that scenario. And it's a good thought example on how things can go wrong. So what would you expect to happen? Or what would you want to happen? So what actually happens is that the holograms will drive away. And of course, eventually you get lost, because that's your whole map driving away as well. There's no new map here currently. If it drove away slowly enough, it'd probably be OK. But in this example, the bus drove away too quickly. So this is one of the things that you said, why don't we have it automatic? This is one of the reasons we don't, because you can imagine that replace the bus with a production line where there's cars going by. So you're not inside the car anymore, there's cars going by, and you're doing your welding or whatever. Someone might have designed a very expensive, nice application for some company that paid a lot of money for it. And that's all working currently. And then we make moving platform mode default, and suddenly the things they expected to stay stationary, perhaps they have a workstation that's fixed to the deck where they are, and the cars drive by and they have buttons that stay where they are. Now their buttons are going to drive away with the production line. And so we're a little worried about existing applications being broken by this mode for those kind of esoteric examples, and those things we thought would be very hard to predict ahead of time. Like we couldn't, if we knew who those customers were, we could go talk to them and ask them if it was a problem and try it with them first, and if it wasn't a problem, then it would be OK. But I think there's so many of these strange examples that could happen, and it might happen to just one-person teams or something. We of course care about those guys too, but we might not have the resources to go and help and check everyone's system. So this is why it's not default. One of the reasons why it's not default. OK, and so we do have a few unsolved problems. Again, I wouldn't necessarily say these are bugs. These are just the way the world is. So hand momentum is a big one. So if you're in a car, in the passenger seat, of course, and you're trying to use an interface that's designed for someone in a stationary environment, they're going to have buttons that are somewhat small, compact. There's going to be text that's a natural size for people to read. And then they're going to try and press the buttons. But of course, you go over a bump, your hand has momentum. It's not going to be very accurate. And so this comes with a recommendation that if your user interface is only for use in a vehicle, let's say your app is entirely a HUD for a car or something like that, then make sure your buttons are bigger than they usually would be, because people aren't going to be able to press them because they go over a bump and their hand's going to miss. There's also the harsh transitions thing that I mentioned with the elevator, where you go from moving to non-moving environments. This is not handled super gracefully at the moment. It's all one map. It tricks itself into being stationary. So there's, if you get in your car, you build your map on your way to your car, you get in the car, there's a map inside the car too. You drive away. The entirety of your driveway comes with you. You park your car at your work or wherever you're going. You get out, and then you start building your work car park on top of your driveway. And it will continue tracking fine, but you will end up with this, over time, the map gets more and more corrupted, and it'll get less and less reliable. So in a one-off kind of use case, I don't think you'd notice a problem. But if you're going back and forwards every day, your map gets corrupted, which can be solved by clearing the map. But then, of course, your application needs to deal with the fact that you're losing your anchors potentially. You might have to re-anchor them. So there's some work for the developers to do to ameliorate that problem. And potentially in the future, this will be a problem we solve at the driver level, maybe. And of course, vehicles with no cabin. So people also ask, will it work on my motorbike or a normal pedal bicycle? No, though the HoloLens should theoretically work without moving platform mode, because your cameras are looking at the environment, which is part of the inertial frame in this case, because it's the trees and the roadside and stuff are part of the planet. And so they fit with the normal assumptions of head tracking. But of course, in reality, if you're going very fast, the head tracking probably will fail. If you're outside in bright lights, we don't formally support outside tracking, especially in larger environments like fields and things like that. It does work in more confined areas where there's walls and things to track off of. But yeah, don't expect it to work with vehicles with no cabins. Okay, and that brings us to the end. And so I'll leave it on the thank you slide. Thank you very much. Thank you for listening. And I believe we have a few minutes for questions, if there's any questions. Okay, best practices for ASA, Azure Space Rankers. It should be the same as the normal best practices. Again, it's tricked into being stationary. We have made accounting for the fact that ASA uses down direction, or the gravity direction, in fact, to do some pre-pruning. And we've made sure that we turn that off when we're moving platform mode. So it might be a bit slower to reloc using ASA because it's, well, maybe not using ASA. So I'm thinking about the on headset relocation stuff. Using ASA, it should be all of the standard recommendations should work. You would probably end up with problems if you change the down direction. So if you set a down direction, save an anchor, and then you do this and say set down direction again and try and recall it, the optimizations that filter based on down direction on the server side are probably going to cause that to fail. So keep down direction in the same direction from when you set the anchor and to recall the anchor would be good. Yeah. There probably is a way you can request it. This would be one of the ways. So we have thought about that actually as part of our, when people ask questions about accessibility, like could we set down direction for someone who's in a bed or something like this? And we have thought about that. If you send me an email, I can give you my email. That will give me something to reference when asking for this upstream. Yeah. Yeah.
Are there any sensitive? The sun at different.
So the display should be okay because they're like a laser situation. So I don't think they would have any problems, like with a burning of an LCD would, for example. The cameras, I guess, could have some issues that are overexposed. But my personal belief is there shouldn't be anything that's a problem with bright light. I've taken HoloLens into lots of bright light before, and it's fine. Though, of course, this doesn't come as a warranty.
Yeah.
But yeah, it's.
Like 10 headsets out. And just even
This is with a VR headset.
Yeah.
Yeah, I can imagine with the lenses onto an LCD that could be an issue, but for the HoloLens, I don't expect the display technology to have any real way of getting light back into the display engine. Yeah, it would. I think there's a question at the back, or is that answered? Mm-hmm. Yes, so you can, though we haven't managed that at the driver level. So, okay, the question was, can we put HoloLens graphics outside the vehicles and have them fixed to the like the roadside or whatever? You can do that, though you have to manage that yourself. So, if you had some GPS source, a GPS track of your car that you were getting separately within your app, and then you were doing the maths yourself and saying where those holograms should be, you can do it yourself. It's not done at the driver level at the moment, because we don't have any way of getting the GPS data in, and we haven't sorted that out. You can do it, and people have done it. So you can do it. But it's all up to the developers at the moment to do the working out of those coordinate frames. Yep.
Yeah, in the car experiment, you said
So I haven't had any problems with the sun, actually, not too much. I haven't driven at night, just haven't got around to it. So I would expect the tracking to not work very well in the night because there's only going to be a few LEDs that are visible. And most of the stuff outside will be visible because of street lights and other cars. And that's going to confuse the system because in the same way that the car's moving in a non-inertial frame but also not fixed to your car is going to confuse it in the same way that the original system gets confused by moving platforms. So I wouldn't expect it to work at nighttime. at all. But I haven't had any problems with the sun up till now, although it's a theoretical problem. At the moment, there's no supported way of doing that. It believes it's in one map, so there's only one kind of anchor. This is something we're certainly thinking about, and if there's in the future, we hope to kind of answer some of these questions, but we're still working on the technical solutions to those. Okay, seems like we're clear. Okay, thank you very much.